Hi. In today's video we're going to talk about the slope function in SQL Server 2008. If you remember from high school geometry, slope measures the rate of change in x over the rate of change in y. In XLeratorDB SLOPE function we do exactly the same thing. Here we put together a very simple example. The function is invoked using slope, y, and x. And here we've calculated x as 1, 2, 3, 4, and 5, and y as x divided by 4. So we're going to go through and execute this select statement, and we can see that we correctly get a slope of 0.25. But the slope function is a very, very powerful function. We can do far more with it than simply calculate simple slope examples like this. So for the rest of our examples, we're going to refer to a table that I've set up called equity prices. And if we look over here at the equity prices table, we can see that it consists of 4 columns. A ticker, which is a symbol that identifies the equity, a T-date, the date that we've recorded the price for, the closing price from the previous day, and the closing price for the value of T-date. And we've established a primary key on this table of ticker and T-date. Okay? So the first thing I want to show you is how many rows we have in this table. So we're just simply going to count the number of rows. We can see that we have 1,013,897 rows in this particular table. And what we're going to do in these examples is we're going to calculate something called beta. So the beta is the relationship between the change of price in a security and the change in price of some index that it's being measured against. So in this particular example, the index we've identified as a ticker of GSPC, which is the Standard & Poor's 500. Okay? And we're then going to compare this index to all of the tickers that are not GSP, where the dates are the same, okay, and where the dates are greater than the 1st of January 2011. So we're calculating the beta from the 1st of January 2011 to the 20th of July 2011, and we're doing it on over 1 million rows worth of data. So let's see how long this is going to take. We hit execute, and there we are. 500 rows, representing the 500 tickers in the S&P 500, are returned in less than a second. There wasn't even any time for the clock to run on the results of this particular query. But, 500 rows is still a lot of data to analyze, and perhaps we can do a few things that might make this query a little bit smarter for us. So in this particular example, we're going to actually look for all of the securities that have a high beta. In other words, the beta is greater than 1, which means that as the price of the index changes, the price of the underlying security changes faster. So if the index goes up 1% a day, we expect the security to go up more than 1% in that day, or if the time period is a week or a month. But we're interested in securities in tickers that have a beta greater than 1. So we can identify that by using essentially the same SQL we had before, except we can add a having clause right here. And we're going to say, give us everything where the slope is greater than 1. We run that query. And again, blazingly fast, very simple. And it returns all of these tickers, there are 19 of them in all, where the beta is greater than 1. So since we're interested in all of the securities where the beta is greater than 1, perhaps we might be interested in securities where the beta is less than -1. So in fact, the security is moving directly opposite to what the index is doing. And in fact, if you're trying to construct a portfolio that has non-correlated risk in it, this is an excellent way to do that. So we are going to do exactly the same thing we did before. We see we get 22 rows where the beta is less than -1. We use the having clause in order to specify what kind of information we're interested in. And again, very simple, very, very powerful execution of the function gives us the information we're looking for in a split second. Finally, we're going to look at one more type of calculation we can do. And in this example, we're going to change the way that we calculate beta. So we're actually going to calculate a 1-month beta, which is what is the relationship based upon the daily price movements between the underlying securities in the index over the last month, and a 3-month beta, which is essentially the same calculation, except we're going to look at a time period for the last 3 months. So We're clearly using aliases and joining the table to itself 4 times in this particular example. So we can see we have an E1, E2, E3, and E4 aliases. We specify the conditions that we want to do our calculations on, and we're going to look for, in the first part, the 1-month beta, we're going to look for everything that's between now and a month ago. And for the 3-month beta, we're looking for everything that's between now and 3 months ago. And so now we're going to go through and we're going to do this calculation again. Lots of data, and we can see that we get the result in about 2 seconds, which gives us back all 500 rows. And of course, we could calculate 1-month beta, 3-month beta, 6-month betas. We can look for changes in the beta where we've gone from positive to negative, or negative to positive, or greater than 1 to less than 1. There's all kinds of analyses that you can do that you certainly wouldn't be able to do in Excel, because you're not going to export 1 million rows worth of data to do this analysis in Excel. And it's very, very easy to do, and it's very, very powerful. I hope you're able to make this function work for you in your environment the way we've been able to make it work here today.